The idea of piecewise equations, piecewise functions are not anything new from things that we've done probably all the way back to Algebra 1, but they are definitely things that we don't really hammer home as much as we probably should. So I want to spend a little time here and look at some piecewise equations. All right, for piecewise functions here, let me make sure we're fully in. In piecewise functions, what we need to be looking at is different portions of a function based on what the x values are. So the first part that we'll have to do is to analyze and find what an actual function value is. So just like we did before, f of -3 means I'm plugging in -3. Well, with a piecewise function, I need to figure out which one of these three regions is the correct region to plug into. Well, -3, is -3 bigger than 9? No. Is it between -1 and 9? No. So this is the region, being less than -1, that I should look at. So I need to plug in -3 into this portion of the equation. So 4 times -3 plus 6. So this equals -12 plus 6, which is -6 as your answer. For number 2, when f of -1, so which region does -1 work out? Well, that would be this region right here, because it's between -1 with the equal sign and 9. So I plug in -1 into that equation, -1 plus 3, which is 2. If I want to know f of 0, well, 0 again is in this middle region. So I plug in 0 here. So 0 plus 3, which gives you 3. For number 4, f of 9. Okay, well, which one of these two regions is it? This is the one that has the equal sign. So I need to plug it into the bottom part. So I'm looking at the last function, the square root of 9, which is, again, also 3. f of 14, well, that would be, again, this region because it's bigger than 9. So I'm going to do the square root of 14. Do I know the square root of 14 off the top of my head? Absolutely not. So that means, oh well, I'm not going to try to get a decimal. I don't need to get an exact value in decimal form. This is a precise answer. I would rather you leave it like that. AP readers would rather you leave it like that than to try to find any sort of decimal equivalent. All right, now what we should have been able to do 1 through 5 hopefully pretty easily. 6, 7, and 8 are the new ideas when it comes to piecewise functions, talking about continuity. So just for an idea of what's going on with this graph, let me kind of graph out what it looks like. Okay? Until we get to -1, we have some graph and some function that's going up pretty quickly. It's 4x plus 6. So it probably looks something like this. Okay? From -1 to 9, I have another function going on. Excuse me. X plus 3. So what's happening here is I have some function that maybe doesn't rise as quickly, but that goes until you get all the way up to 9. And then I have the square root of x starting at 9. So the square root of 9 is 3. So we have something that maybe looks like, and we said our graph of a square root looks like that. So that is what kind of our function looks like. Now, for it to be continuous, what that means is, well, for this function, do these points actually match up either at this point or that point? Or maybe if I rotated it, maybe at both points, that sort of thing. That's what we need to try to figure out. And here's how we do that. For it to be continuous at -1, well, here's where the breakpoint of -1 occurs. It's between these two guys. So what I'm going to do is I'm going to plug in -1 at into both of those functions. So if I plug in -1 into the top function, so 4 times -1 plus 6, we get a value of 2. If I plug in -1 in the bottom part, -1 plus 3 also equals 2. So what that means is, as I plug in -1 for both sections, I get the same y value. That y value here is 2. That means that, yes, it is continuous at that point. That's all you have to do is plug in to both sections around the breakpoint. Now, for at 9, well, here's 9 here, so I'm going to now plug in into those two guys. So if I plug in 9 into the x plus 3 part, I would get 9 plus 3, which equals 12. If I plug it to the bottom part, square root of 9, which is 3. Are those the same number? Not even close. So since 12 and 3 are not the same, these guys are not continuous. So again, what that means looking at the graph is that these guys here have a little jump. They do not go to the same point like this guy does. So is it continuous everywhere? Well, if it's not continuous at 9, so it can't be continuous everywhere either. So to be continuous everywhere, it just has to match up at every single breakpoint. So we're going to do a lot of stuff with these piecewise functions. We'll talk about piecewise continuous, piecewise differentiable we'll talk about down the road, but it all comes down to do you know how to plug into a function like we did in 1 through 5.